Hi there, this is TK and welcome to Matrix Uploaded. And you know when you see me, it's physical sciences, and today it's lesson number 16. We are going to talk about separation of particles and chemical change. And of course, we're talking chemical change in these two lessons. Previous lesson, lesson 15, was also about chemical change, but we're taking it further. Now, as usual, we're taking it from grade 10 to 12, so you go nowhere. We're catering for everybody. You sit there and be part of this lesson. You're gonna enjoy it. It's gonna be helpful to you. Now, let's have a look at the difference between physical and chemical change. Okay, what we know is that substances may undergo two types of changes, okay? One type of change is physical change, and the other is chemical change. Now, what happens during physical change? During physical change, what we see happening is that particles of a substance do not change, okay? But there is rearrangement of those particles. Think of a situation where you've got ice water left out in the open in a burning sun. The ice water is going to melt. In ice cube form, it is solid, but it is water molecules. When it melts into liquid, it is still water molecules, H2O. There has been a physical change between solid water, from solid water to liquid water. So here we will speak of a physical change. So during physical change, the substance do not change. The particles of the substance do not change. Like I gave an example of H2O, ice, and H2O, water. So this is solid, this is liquid. But in both cases, we're still talking H2O. Okay, so these particles of this substance are just rearranged, but the particles or the substance retain its chemical properties. The chemical properties haven't changed. And in between there, when we have change in, when we have physical change, we have weak intermolecular forces to overcome. In other words, we don't have too much of strong bonds to break so that new bonds can form. All we are doing is to separate one molecule from another or from the rest, okay? Because one molecule could be attached to many around it, like in a crystal lattice where you will have a molecule here, another one there, another one here, up here, and down there, also this side and that side. So that arrangement is broken. The intermolecular forces, in other words, the forces that exist between two molecules to keep them together, are weak. So all you need to do is to overcome them to change the physical structure of that particular substance. So from a solid structure to a liquid structure, for example, but still keeping the chemical state or the chemical properties of that molecule. Now, when we come to chemical change, something here becomes different as compared to physical change. The particles of a substance are changed into new ones when we have chemical change, okay? If you have hydrogen and oxygen reacting, this is one of the simplest ones that every science student or learner should know. H2 plus O2 giving us H2O. You would see that this is a particle. It's a water molecule particle. That's a particle of hydrogen molecule, the diatomic molecule of hydrogen. That's another particle, molecule of oxygen. When they interact, these bonds here have to be broken. So hydrogen to hydrogen bond has to be broken. Oxygen to oxygen bond has to be broken. And the the new bonds, hydrogen to oxygen and oxygen to hydrogen, are to be formed. There is a complete rearrangement of particles in this process, and therefore this is called a chemical change, because at the end we have something completely new to what we started with. So particles of a substance are changed into new ones during chemical change. New substances are far different from the original ones. The H2O molecule is far different to the hydrogen molecule and the oxygen molecules that were involved in the reaction at the beginning. Strong chemical bonds are broken during this reaction. I have shown that you have to break the bonds between hydrogen and hydrogen, oxygen and oxygen, so that there can be interaction between hydrogen and oxygen hydrogen. Okay, so you have to deal with very strong bonds. You have to break them so that you can have new bonds forming. Okay, and that is what happens in chemical change. And in this reaction here, for example, you are forming hydrogen and that new thing from zinc and HCl, completely new substances. See you in the next section.